This video is for Math 112, trigonometry, and this is the follow-up video for section 3.1. So I've got the Pythagorean identities here, the reciprocal identities, and that identity for tangent, and then the four strategies that I think are really helpful in solving trigonometric identities, writing everything as sines and cosines, making a common denominator and adding or subtracting fractions, doing the opposite of that, which is splitting a fraction, and then also factoring and canceling something out. Okay, so let's pick up where we left off, problem 18. So, let's see what we've got here. Cosine theta over 1 plus cosine theta minus cosine over 1 minus cosine theta, and then we want this to come out as negative 2 cotangent squared theta. So we've got these two fractions. They have different denominators. That kind of lends us to, strategy number 2 here. Let's make a common denominator out of this. So the common denominator is going to be the product of these two together. This one needs to get multiplied by 1 minus cosine over 1 minus cosine, and this one needs to get multiplied by 1 plus cosine theta over 1 plus cosine theta. Alright, so that's going to make our common denominator, the product of these two. And you can skip that intermediate step right here and just multiply them out if you want to. It's going to be 1 minus cosine squared, which we're going to eventually replace with a sine squared, is where we're headed with this. Up on top, we're going to have cosine times 1 minus cosine, and then minus cosine times 1 plus cosine theta. And I'm just going to leave that cotangent squared alone. There's not a whole lot that we can do to it, but let's keep working over here, and then we'll see whether or not we need to change that cotangent at all. All right, so up on top, I'm going to distribute, so we'll get cosine theta minus cosine squared theta here, and then minus cosine theta minus cosine squared theta. These two are going to cancel each other out. Down at the bottom, 1 minus cosine squared theta. So on the top, we have negative 2 cosine squared theta. And then on the bottom, again, this is what I said a minute ago, is we're going to replace that 1 minus cosine squared with just a sine squared. So there's your cotangent right there, and there's the negative 2. So this is going to be negative 2 cotangent squared theta equals negative 2 cotangent squared theta. And we're done. Okay. Got a little bit complicated in through here, these first couple steps. But once we did that, everything worked out pretty nicely. We didn't have to really do a whole lot after that. Okay. That's problem 18. Got here. Problem 20 is very similar. I'll go ahead and do that one anyway, but this really is the same problem, but with different trig functions. Okay, and you can see the similarities. We're going to make a common denominator here, and then we're going to use this identity to replace the denominator with just a single denominator that just has a single term in it, and then that should allow us to make some simplifications. So let's see where we go with this one. It's going to be exactly the same process, right? We're going to multiply, we're going to make a common denominator, which is going to end up being 1 plus secant times 1 minus the secant, right? The product of these two. So this one gets multiplied by 1 minus secant theta over 1 minus secant theta. This one gets multiplied by 1 plus secant over 1 plus secant. Okay, so now we've got the common denominator. Up on top, we're going to have tangent theta minus tangent times secant. Now, let's see here. All right. And then we're going to have minus tangent theta and then minus tangent theta secant theta. All right. And then we want to show that this is 2 times the cosecant. So this tangent and this tangent cancel each other out, and we end up with negative 2 tangent theta, secant theta on top, and 1 minus secant squared theta on the bottom. That's the product of these two together. Let's see here. So 1 minus the secant, if we look at that identity right there, right, if you take that tangent squared plus 1 equals secant squared. Let's swap sides, right? Subtract the tangent squared on both sides, subtract the secant squared on both sides. So those cancel and those cancel. 1 minus secant squared is negative tangent squared. Okay, so that's going to be our denominator then. All right, let's see here. Let's go in this direction. Negative 2 tangent theta, secant theta on top, and negative tangent squared theta on the bottom. And again, we want to show that this comes out to be 2 times the cosecant. All right, well, first of all, these two will cancel each other out. And so that'll make this positive, which is good, because that's where we're headed over on the right-hand side. And what else? This tangent will cancel out one of those, and so we'll have 2 secant theta over tangent theta. We're still headed in this direction. At this point, I would rewrite everything in terms of sines and cosines. And so let's see here. On the top, this will be 2 over cosine theta on the top, and then sine theta over cosine theta on the bottom. So 2 over cosine theta multiplied by the reciprocal, and those cosines cancel out. 2 over sine theta is 2 cosecant theta, and that's what we wanted. I got kind of, I'm trying to keep everything in line with each other, but I kind of ran out of room at the bottom there. And so I just went in this direction right here. Okay. All right, so that one wasn't too bad. It was similar to problem 18 at the beginning, but then once we got to this point, we had to do a little bit more than we did in problem 18. We had to introduce the sines and cosines to demonstrate that this actually is the same as the cosecant. Okay. Let's see what else we've got here. Problem 22. Cosecant squared on top, 1 plus tangent squared on the bottom, and we want to show that this is equal to the cotangent squared. All right, well, the 1 plus tangent squared we've got as an identity, and anytime, especially in the denominator, anytime you can collapse 2 terms down to 1 term, I think that's a really good idea. So let's replace that with secant squared. And then I guess writing this in terms of sines and cosines would be a good step forward. So the cosecant on top is 1 over sine squared theta, and the secant on the bottom, 1 over cosine squared theta. And then multiply by the reciprocal. And this is cosine squared over sine squared. And and yeah, that is the cotangent squared. And there we go. Okay, well that one was pretty straightforward. Really the only thing we had to do here is replace that one with a single term and then rewrite this in terms of sines and cosines. That was pretty straightforward. Okay. Let's see here. Problem 24. Kind of interesting. Let's see here. So cosecant to the fourth minus cosecant squared equals cotangent to the fourth plus cotangent squared. Well, both of these have a similar setup, which is that they can be factored, right? We've got a common factor on the left-hand side of cosecant squared that we can factor out. And then over here, we've got a common factor of cotangent squared. Now, we could just work on the left-hand side and turn it into this one, but you know, we don't have to. We can work on both sides and just turn them both into the same thing. But we don't want to trade back and forth between the sides. All right, so let's see here. Now, these should set you to looking at the Pythagorean identities. Cosecant squared minus 1, that's cotangent squared. Over here, cotangent squared plus 1 is cosecant squared. And we're done, right? There it is. It's the same thing on both sides. So that factoring, recognizing that you had a common factor in each of these, I think was really helpful. Okay. So let's see here. Yeah. All right, let's look at problem 26. All right, so 1 minus sine squared over 1 plus cosine, that's equal to cosine. Well, let's see. I'm seeing two ways to start out here. So maybe I'll do both. But in any event, the one way we can start out here is make a common denominator. This is 1 over 1. We'll give it a common denominator of 1 plus cosine. And then let's see here. So this will be 1 plus cosine theta minus sine squared theta over 1 plus cosine theta on the bottom. Well, I guess what I would do at this point, and this was the other thing that I was thinking of, another way to start this problem is to replace that sine squared with 1 minus cosine squared. Now you have to be careful if you're going to do it at this point because it's going to get parentheses. And then 1 plus cosine theta. So we distribute the negative sign inside there and we get 1 plus cosine theta minus 1 plus cosine squared theta over 1 plus cosine theta. So these 1's cancel each other out and we end up with cosine theta plus cosine squared theta over 1 plus cosine theta. And this is the point where it's really important to recognize that up here on the numerator, you've got a common factor. And once that gets factored out, those two cancel and we're done. Okay? So that's why I said that was the key, is to recognize that you can factor and cancel there. So you can see that we did made common denominators and factored and canceled there. Okay, so let's see what would happen if we made that replacement that we made here. What if we did that before we made a common denominator? What would that look like? Let's see. So we start out 1 minus sine squared over 1 plus cosine. So what if we replace that with 1 minus cosine squared? So now, it's at this stage that you can realize this is a difference of squares. That's 1 plus cosine times 1 minus cosine over 1 plus cosine theta. Those cancel, and we get 1 minus parentheses 1 minus cosine theta. 1 minus 1 plus cosine theta is just plain old cosine theta. So, this is another way to go about doing problem number 26. But again, you have to recognize first off that you want to replace the sine squared with 1 minus cosine squared, and then you can factor this as a difference of squares, and so it'll cancel out that denominator. And you won't have to make a common denominator the way that we did in this method right here. So, either one is fine. They both work. They're both correct. You know, that's the thing about doing these problems, getting the experience of understanding how they work and what you are likely to see as you're working through them, I think is very helpful. So let's see here. Problem 28. 1 minus sine theta over the cosine, and then cosine theta over 1 minus sine theta. Okay? And what's that going to be equal to? 2 secant theta. Well, it looks like making a common denominator is the way to go here. So this will get multiplied by this denominator, 1 minus sine theta over 1 minus sine theta. This one gets multiplied by cosine theta over cosine theta. So, what do we get out of that? Our new denominator is cosine theta times 1 minus sine theta. You can multiply that through if you want to, but it doesn't really take us anywhere. So I'm just going to leave it alone. Up on top, 1 minus sine theta times 1 minus sine theta plus cosine squared theta. Alrighty. So we're going to have to multiply those two together. FOIL them, as some people say. So this would be 1 minus 2 sine theta, and then plus sine squared theta, plus cosine squared theta. Alright, so here it is right here, sine squared and cosine squared, that makes 1. So this will be 1 minus 2 sine theta plus 1. So that's 2 minus 2 sine theta, and then we want to factor out that 2. So this will be 2 times 1 minus sine theta over cosine times 1 minus sine theta, and now we're almost done. 2 over cosine theta, is that 2 secant theta? Yep. Okay. So there we go. So the whole thing came out of making this common denominator and then understanding how to multiply this out. That's I'm surprised at how many people forget their basic algebra. But it's important that you understand how to do that multiplication there, and that'll generate a sine squared to go with that cosine squared. That makes 1. And then the 1 in this one make a 2, which you can then factor out and allows you to cancel out the 1 minus sine theta on the top and the bottom, and then that leaves you with 2 over cosine theta. All right. Well, we've got a couple more to look at. Now let's see what they look. they involve. Okay, problem 30. Let's see here. Tangent theta minus cotangent theta on top, and tangent theta plus cotangent theta on the bottom. And then we want to show that that's equivalent to sine squared minus cosine squared. Okay. Well, we don't have any identities right away. I mean, we could replace one of these with something, but that's not really. I don't see that taking us anywhere that is really going to generate this expression right here. So I'm hesitant to do this because it's kind of, you know, it's a lot of work, is rewriting all of this in terms of sines and cosines, and then adding them together by making common denominators. So let's see how that goes. So this is going to be sine over cosine minus cosine over sine. Alright, that's the numerator. In the denominator, it's going to be the same thing, except plus cosine over sine. Alright, so now we've written these in terms of sines and cosines. Now we're going to make common denominators and subtract here and add here. So this one, our common denominator on both the top and the bottom is going to be sine theta cosine theta. So this one needs to get multiplied by sine over sine, and this one gets multiplied by cosine over cosine, and we'll do the same thing down here. Okay, so if we do that, now on the top, we've got a common denominator of sine theta cosine theta, and on the numerator of that one we'll have sine squared minus cosine squared, which is nice because that's where we're headed. Okay? So if we can just get everything else to cancel out, we'll be done. Alright, on the bottom we've got the same denominator, sine theta cosine theta. And then the numerator down there will be sine squared plus cosine squared. Okay, so, like I said, it's kind of a lot of work to rewrite everything and make those common denominators, but now we're set up to finish, okay? Because down here, that sine squared plus cosine squared, that's going to be 1. So we'll leave this one the way that it is. And then in the denominator, 1 over sine theta cosine theta. Okay? And then the next step is we're going to take this multiplied by the reciprocal. So the top will stay the same. And then that'll get multiplied by sine theta cosine theta over 1. Those cancel. And there we go. Sine squared theta minus cosine squared theta. And that's what we wanted. Okay. Again, like I said, this is a little bit tricky in here. But once you get past that, then things work out pretty nicely. All right. Let's look at, we got one more here. Problem 32. Looks very similar to this one. Let me write it down and then we'll take a look at it and see if there's anything, another way to approach it, or whether we're going to do that same, writing everything as sines and cosines and then make common denominators for it. Okay, so problem 32. Secant plus tangent on the top. And on the bottom, cotangent plus cosine. All right. to show that this is equal to the tangent times the secant. Well, I'm less hesitant to write everything in terms of sines and cosines on this one. It seems like it makes the most sense because we don't have anything being squared, so we can't use these Pythagorean identities. So I think I'm going to fall back on this. So the secant is 1 over the cosine. Tangent is sine over cosine. Look at that. We've got a common denominator. We don't even have to do anything. Let's see here. On the bottom, though, we've got cosine over sine plus cosine over 1. So we will need to work with that bottom piece. Here, this is sine over cosine times 1 over cosine. So this is where we're headed. Sine theta over cosine squared theta. Okay. Well, let's see here. On this one, we're going to have 1 plus sine theta on top, cosine theta as the denominator. All right. Down here, we're going to have to make a common denominator. So we're going to have to multiply by sine theta over sine theta. So that'll be cosine theta plus cosine theta sine theta on top, and our denominator is sine theta. All right, so I don't see anything right away that we can make a replacement. So I'm going to take the reciprocal of the denominator, multiply it by the numerator. Okay, sine theta over cosine theta plus sine theta cosine theta. So at this point right here, the key to doing this problem is recognizing the common factor here. Factor out the cosine, that'll leave you with 1 plus the sine. That cancels those out, and we're left with sine theta on top, cosine squared theta on the bottom, and that's what we wanted. Okay, so you can see this factor and cancel comes in handy. I don't think we really saw any split a fraction examples, but that is also helpful as well. And we saw a fair number of doing everything in sines and cosines and making common denominators. And so those are good strategies, I think, for solving these identities. So that's it for section 3.1. We'll introduce a couple new identities for section 3.2, do some more problems, and then we'll move on to the second half of chapter 3, which is about solving equations involving trigonometric functions. As always, if you have any questions, please let me know. Thanks.